Okay, so we're here looking at how to write the formula, how to name a compound that has a polyatomic ion. Well, our first step here is to know what our polyatomic ions are. So, as we've learned a couple times before, we go ahead and repeat O, no, so, co, po, clone. Well, that's the first thing. It gives us the types of elements in each one of these. Next, we need to know how many of each element we have. NO3, so that's 1 nitrogen, 3 oxygens. So SO4, 1 sulfur, 4 oxygens. CO3, 1 carbon, 3 oxygens. PO4, ClO3, NH4. Each one of these is going to act as a whole unit. So we've got CO3, 1 carbon, 3 oxygens, all acting as one big old clump. All right, so one unit. They don't ever separate. Next thing, since these are all ions, they all need a charge, and they go -1, -1, -2, -2, -3, -1, +1. Okay, now that's all. Not all. We also have 3 other ones that have the same elements and the same charge, but 1 fewer oxygen. Okay, we've got SO3 with a -2, and we've got ClO2 with a -1. Now, everything up top here is named 8, everything down the bottom here is named 8, and it's all based off of this first element. So carbon in the 8 row is going to be carbon 8, sulfate, nitrate, chlorate, phosphate. These guys in the ends have funny names. This one named hydroxide. This one named ammonium. Okay, so with that out of the way, we can go ahead and get started and naming some of these compounds. We'll start off with this one, Ca in parentheses NO3 2. So let's break this down. We've got a couple different parts. First off, we've got the calcium. We know what calcium is. Now, usually when we've been naming ionic compounds, we need to figure out the name of the element here and then cut the ending off and replace it with "ide." Well, since we're dealing with a whole bunch of elements here, all we've really got to do is figure out what is the name of this unit. All right, this unit's name, we go up here and we find it, here, NO3, the -1, and it's in the 8 row, so this is nitrate. This is calcium nitrate. And that's all we really need to do for this one. Let's see one that gets a little bit more complicated. We'll fold the paper up, leave our polyatomic ions visible, and see how we're doing. So let's look at this next one. We'll try NaOH. Well, there's no parentheses here to tell us whether or not we're dealing with a polyatomic ion. We're just going to need to be able to recognize it. What can help us is the fact that we know that sodium has got to be a +1. So that means everything else that it's bonded to has to total up to a -1. So if we know that, we've got an OH that we know has to total a -1, and we find that right here. OH with a -1, it's got to be hydroxide. So we'll just go ahead and name this thing sodium hydroxide. And that's as simple as that is. Let's go ahead and look at a couple of other examples. We've got all of our polyatomics already written out here, so let's go ahead and move on to something where we have to use a transition metal. Okay, how about we'll try this one, SnClO2 4. Okay, well, we've been naming things with transition metals before, all right, and they all follow the same general pattern. We need to find the metal, and we need to figure out what it's bonded to and what the charge is. Okay, well, I know what Sn is. That's tin. Next thing is to figure out what this thing is. It's ClO2. I find that up here. Well, it's a little scrawled out a little not so neatly here, but ClO2. And the most important thing, this has got a -1 charge. So I'm going to write in that -1 charge just to remind us. Now, ClO2, it's in the ite row, so chlorite. So this is tin something chlorite. Okay, next let's figure out its charge. Okay, so we've got a ClO2 with a -1 charge. except that what these parentheses mean is that I've got 4 of them. So instead of just a single -1, I've got 4 groups that all each individually have their own -1. I've got ClO2 minus 1, ClO2 minus 1, ClO2 minus 1, ClO2 minus 1. If I total all that up, it gives me -4. So total negative charge over here of -4. That has to be balanced by a +4. What I've got to do is take my +4 and divvy it up evenly among all of my metal ions. Well, since I only see one, I'm going to divide it by the one tin that I see, and I get a +4 charge. That tells us that this is tin 4 chlorite. You got to write it with the Roman numerals. Okay, so that's going to be the name of this guy, tin 4 chlorite. Well, let's see one that's in the same vein, but that might need a slightly different approach. Fold it over here. Hopefully that's not bleeding through too much. And we take a look at this one here. Cu2SO3. Okay, well, I know what Cu is. That's copper, and it is indeed a transition metal. SO3. Well, I see an SO3 right here. And so let's go ahead and name this thing. It's in the ite, and it's got a sulfur, so it is sulfite. Sulfite. All right. Now here's the trick. Figuring out how many sulfates I have. Since I don't have any parentheses here, and sulfite is SO3, well, check it out. SO3, SO3. I have no parentheses here, so that just means this is sulfite all by itself, which has a -2 charge. Okay, since there's no parentheses, it means there's only one sulfite group right here, and it's got a -2 charge. So we have a single -2. Over here, balanced by a +2. Well, this +2 has to be divided evenly among both of my coppers. So I'm going to take my 2, divide it by the 2 coppers, and I get a +1. That tells me that this is copper 1 sulfide. We've got 3 more that we want to see. Okay. How about this one? Fe2, in parentheses, CO3, 3. Okay, once again, we separate the metal from the polyatomic ion. Fe is iron. CO3 up here, its name is carbonate. Now we've got to figure out what's the charge. Carbonate up here tells us the charge is -2, and I've got 3 of them. So I've got a total of -6, which has to be balanced by a +6. I take my +6, I divvy it up evenly over my 2 irons, and I get a charge of +3. It means each of these irons has a charge of that +3. This is iron 3 carbonate. Okay. A couple more here. HgSO4. Well, I know what Hg is. We look it up on the periodic table. Why am I writing Hy? This is mercury. SO4's name is, find it up here, it's SO4 and it's got a -2 charge and it's in the 8, so this is sulfate. Okay. Now, again the question, how many sulfates do I see? There are no parentheses, so this is just a single sulfate unit. Okay, SO4 with a -2 charge. Got to be balanced by a +2, and since there's only one mercury here, that mercury has to take the whole +2 charge. Okay, so mercury 2 sulfate. 2 more. First one, NH4 in parentheses with a 3 outside of it, followed by a PO4. Well, here we've got a whole bunch of elements, so none of the rules we've learned really matches up quite yet. What we have to do is recognize that this is our friend ammonium. And this is our friend phosphate. So all we've got to do in this case is just name it. Ammonium phosphate. Okay? One other one using this ammonium, since it's the only positive charged ion, it's the only positive charged polyatomic ion. Let's say we end up with NH4Br. NH4, again, we know is ammonium. Br, bromine, but since it's the anion, since it's the one that's coming second, we got to change its name from bromine to bromide. That's pretty much everything you'll need to know for writing names of ionic compounds. Please take a look, shoot me an email if that's a problem.